We are in Precalculus. Today is January 28th. It is a Monday. Make sure your name and date are on the paper. Today is 1/28. Precalculus 6-6 combinations. So let's talk about the difference between, yes.
That's what I said. I'm kidding.
Rochelle. All right. Combination versus permutation. So 6-5 last Thursday that we talked about the difference between combination and permutation. Do you have those notes out? Can you remember what they are off the top of your head? Combination is where?
Order matters.
Order.
No,
I'm joking.
Order does not matter. Order doesn't matter. Does not matter.
In my opinion, it does. Everyone matters.
And permutations where order
Not answers.
does matter. You can underline not and does. So what were the examples? Try not to look at your notes of permutation from last time, from last Thursday. Permutation.
Permutation.
What were some examples? Where do you see them in the real world?
Blocks.
Locks. Good. What are some other examples?
And it's just like security codes or anything like
Security, yeah, everything included with locks. I agree.
that.
Running.
A
Race.
race, yeah, races.
The heck was that?
That was me running. I was running like the Terminator from T2.
You run
Oh,
weird.
good God.
What other things where permutation matters? Or where order matters, where you can have permutations? Usually single file lines, right?
Oh, yeah.
Hey, Mr. Sindel.
Yeah.
Want to hear a joke?
Sure.
My life is a combination.
Because order does not matter.
No, because my life doesn't matter.
Oh,
That's sad.
that is not true. It does matter, Rochelle. That is a lie. That's not a joke. But if order does not matter in your life, like your room is a mess because it's not in order, then that would be funny.
We could say Starbucks too because, I mean,
What do you mean?
I don't know what you mean either.
oh, never mind. Forget you guys.
Your order doesn't matter at Starbucks. They ignore
yeah,
you.
it does.
Oh,
No.
because sometimes
It's a
they
single
would.
file line and then like.
Oh,
the order gets
yeah,
mixed up.
yeah. Who gets to order first in Starbucks? Okay, combination. Do you remember the examples that we gave for combination last time? Where's-
Clothings.
Say again?
Oh,
Put
the
it
way
on
you put
clothes.
on your clothes.
Clothing, yeah. Doesn't matter the order in which you put on your clothes. You're probably going to be wearing a full set of clothes, hopefully, by the time you get to school. What other things?
You come-
I mean, I've heard about parenting strategies, and they say if your kid doesn't want to dress, send him to school with a bag of his clothes. He'll be embarrassed and wear his clothes next time, especially when it's cold out. They'll really change their mind as soon as they step outside. Clothing. What other things? Let me try to do the charades.
Eating?
What are you doing?
A triangle. I'm spinning the thing. I'm eating it.
Pizza?
Pizza
Oh,
toppings.
pizza topping. I don't know. What was that triangle?
Or maybe because it's a pizza. Is it like eating the pizza? No? Okay. What are some other things? Groups. This happens all the time. In ASB, you're always like, okay, who's going to go to the fundraiser? And you have to choose a group. So that would be a combination problem. That's good for now. All right, so let's talk about without repetition. There is with repetition, but that is a very, very ugly beast that we will deal with tomorrow or the day after, sometime soon. So let's say we're playing billiards, or what layman people like to call pool.
Yeah.
So you have these pool balls or billiard balls.
I just think
Let's say we only have 3 balls, numbers 1, 2, and 3. I want to sink those balls. Sink them in the pocket, yeah?
Yeah.
We all can visualize what's going on. So let's assume order does not matter. Is that a permutation or combination?
Permutation.
Wait, what?
Order does not matter. Or sorry, order does matter.
It's
Permutation.
I
Permutation.
can't fucking say it.
So if order does matter, let's list all the possible ways that I can sink the balls. I can do
1, 2, 3.
1, 2, 3. I could do
2, 3, 1.
2, 3, 1. I could do
3, 2, 1.
3, 2, 1. I could do
1, 2, 1, 3, 2.
1, 3, 2. I could do
3, 1, 2.
3, 1, 2. And lastly,
2, 1, 3.
2,
2, 1.
1, 3. There it is. Yep. There are all the possible ways that I can sink the balls where order matters. But usually, unless you're like doing trick shots in pool, it doesn't matter the order in which you get those pool balls or billiard balls in. You just want them to be in the pockets, and you're done. So, when order doesn't matter, how many ways can I sink them?
Just 2.
Which ways? List them.
Order doesn't matter.
4, 5, 2.
Well, no, I still only have the 3 balls, 1, 2, and 3. So
2,
here's one of them.
3.
1, 2, 3. Is there another way?
2, 3, 1.
2, 3, 1 is that all the 3 same ones are still sunk, so it's the same way as 1, 2, 3.
There's no reputation.
There's this, yeah, this way isn't repeated. It's just that one, and that's it.
Oh, okay.
Which is interesting, right? So when we had 3 balls, when it was a permutation, we had 6 possibilities. When it was a combination, we had 1 possibility. We had 1/6 of the combinations, right? So 1/6 of the permutations. So this is 1/6 of this. We can all nod our heads.
Mhm.
We're going to derive the formula. But first, you need to remember the formula for permutations. Do you remember permutations?
Wasn't it
If we have,
fractional?
so I forgot to say that permutation is NPR, like lowercase n, like really, it should be even dropped down. It's called sub n p sub r. It looks like this, but with a p instead of a c. It just means permutation. Permute n r different ways. So it was what on the top factorial? Something on the top factorial?
N factorial
Yep.
over n minus p?
R.
Yeah, you just have n and r to work with. N minus r.
Factorial.
There it is. So that was our formula for doing a permutation. What we're going to do right now is derive what we did for a combination. So in this case, how many different balls, how many different ends did I have?
3.
3. And then how many different ways, or how many different slots did I have?
6.
No. It's also 3, right?
Yeah.
So in this case, I had 3 factorial. I should be doing this all in a different color since I'm actually substituting it in. 3 factorial, all divided by 3 minus 3 factorial. We agree with this?
Mm-hmm.
What is 3 factorial?
It's gonna be 6.
What is 0 factorial?
0.
Nope. 0
No.
factorial?
1.
1. Oh yeah, we never got to the conversation about why 0 factorial is 1. The general answer is because we need to make this formula work. We need to make sure that 0 factorial is always 1. Otherwise, if we're dividing by 0, we have committed a math sin. You've created a black hole. You've done really bad things. It's a curse word in math. So just assume 0 factorial is equal to 1 to make this formula work. So, but this fraction is 1/6 of this, right? So we need to somehow say, now divide this by 1/6. Multiply this by 1/6 to get just one possible way to do combinations. What is 1/6? What is that? In terms of n factorial, n minus r factorial, n r, what is this? Well, we know that 6 is n factorial, right? Multiplied by 1/6 is the same thing as multiplying by 1 over n factorial. Do you agree that 1/6 and 1 over n factorial are the same thing within this problem? Our formula is the same formula here,
So it's flipped.
but flipped, and it's actually not n factorial, it's r factorial. I lied to us. I was thinking if someone would catch it, but it is just r factorial. So here's our formula. Our formula is n factorial all over r factorial times n minus r factorial. Let's try it out. So we're playing the same game, billiards, but as you can see by our picture up here, a normal game of pool is played with 15, I guess 16 balls if you're including the cue ball, but normally just 15 balls. So far so good? All right. How many ways can you sink balls 1, 2, and 3 when all 15 balls are being used instead of our last problem where only 3 balls were being used? All right, so what am I going to do? There's the formula way of doing it, which is what we're going to do right now, and then there's the logical way of doing it. So formula way of doing it. N choose R, NCR. N choose R. What's our formula say? Try to do it from your head, from your memory. What is n and r in this case?
And it's 3.
Nope. Good guess. N is all of the things that I have to choose from. And this is the slots, boxes that I get to choose for. 3. I want to know how many ways I can sink the first, second, and third balls when all 15 are being used. Balls 1, 2, and 3 is another way of asking it. So, what am I going to do? Formula, go. Are you doing it on your paper by yourself? Okay. I'm assuming you're going to do 15 factorial, all of this divided by 3 factorial times 15 minus 3 is 12, so just say 15 minus 3 factorial. So here's how we work with factorials. We say 15 factorial is 15 times 14 times 13 times 12 times 11, and it goes on and on and on, yeah? We know what 3 factorial is. We can just say that. 3 factorial is 3 times 2 times 1, which is 6. So just 3 times 2 times 1, which is 6. Put a 6 up there. And then we have to multiply that by 12 factorial. So this is going to be times, I'll do it right here, 12 times 11 times dot, dot, dot. Yeah? Well, the 12 times 11 times 12 times 11, those things, since they're on opposite sides of the fraction, top and bottom, they cancel out and everything over there is gone. So what I really have is 15 times 14 times 13 divided by 6. So let's do that. 15 times 14 times 13 divided by 6 is 455. So our answer here is 455. Box it. So far, so good? All right, how would I do this if I were just trying to use logic? If I were using logic, it's a little bit harder. Basically, you're doing the same logic as you did before, but remember to divide by r factorial. So, if you're using logic, you'd say, okay, I have 3 spots, 3 boxes. 1, maybe I should do blue here. This is using logic. I have 3 boxes. 1, come on now, 1, 2, and 3. Well, how many ways can go in the first, second, and third box? 15,
14.
and 13. All right. So you're good there, but then you have to say, oh, I'm double counting, well, I guess triple counting. I guess it depends on your interpretation. In order to not make this a permutation, I need to divide this by the number of boxes factorial. So number of boxes factorial. How many boxes were there? 3. So divide by 3 factorial. Change that to 3 factorial, and you'll get the same answer. So that's the logical way, and then there's the formula way. You can choose to do whatever you want, but that is it in a nutshell. We're going on to example 2 unless you pause me for more time or to ask a question. All right, example 2. All right, our high school. We need to choose 2 people to go out to do gate. We have 45 students. How many different groups can 2 people be chosen? This is a real question, right? This is really cool. How many different ways can we do this? And it doesn't matter if I choose, I don't know, Johnny and then Gio versus Gio then Johnny, because it's the same way. So this is definitely a combination question. This is choosing groups.
Wait, but what about the actual athletes? The reason why we have games?
We should have subtracted athletes, huh? Okay, well, let's assume that,
Sucks.
yeah, I should have changed this problem.
Teacher error.
Teacher error. It's not an extra credit point, but I should definitely formulate this a different way. Athletes. This is for next year. I'll change this. Athletes. All right, so let's assume that we're doing gate for the elementary school or something crazy like that. So how many ways can I choose 2 people from a group of 45? Well, this is going to be combination or permutation? Combination. So NCR. What are N and R in this situation? N is
45.
45. R is
2.
2. Do you guys like using the formula or do you like using logic?
Kind of like choosing both. I mean,
Using both? Okay, let's do both. So, formula. Let's do formula first. One of you is in charge of formula, one of you is in charge of logic. Who wants to go first?
do we have to do that?
Yes. Say it louder, Daisy. 45 factorial divided by?
Divided by 2 factorial times 45 factorial. Oh wait, 45 minus 2 factorial.
Perfect. So I'm going to write this all out. It's going to be 45 times 44 times 43 times 42. I think that's good enough. Dot, dot, dot. And then 2 factorial is just 2 times 1. That's going to be multiplied by 43 factorial, so it's going to be 40. Come on now. 43 times 42 times blah, blah, blah. Tell me what to do with this fraction, Daisy.
What?
What do I do with this fraction?
What do you mean?
Does anything cancel out?
The 43 and 42.
Yep, those guys, and everything else, right?
Yeah.
So our new fraction becomes what over what?
45 times 44 over 2.
And I guess you could even simplify the 44 and 2 to make it 45 times 22, but you could just do this, and your answer is 45 times 22, 990. And box it. All right, Rochelle, you're in charge of logic because Daisy did the formula. What am I going to do?
You're gonna draw 2 boxes,
Okay,
and then you put 45, 44 divided by 2.
divided by 2 factorial, or just 2, it doesn't matter either way, right? And then you get the same answer. That is equal to 990. By the way, Rochelle has something kind of cool. Can I show you something cool, Rochelle? Sorry, Daisy. Actually, your calculator might have it. On checking this calculator in front of me, if I go to it might not have it. Oh, it does have it. Do you want one of these calculators? So if you go to PRB, it's probably something.
Oh yeah.
Go over to one that we're going to do it in NCR.
Wait,
So scroll over to this one and enter. Okay.
Oh.
Oh, yes, you can insert. So type in your N, which was in this case 45. So type in 45 first. Then we do probability, go right, enter. 45 NCR 2.
0 2.
So 45 NCR 2.
3.
2.
Oh my god.
So cool. And then for Rochelle, you have the TI-83. Did you already figure it out?
No.
You go to math, PRB, so hit left to get to PRB. Look at these.
Oh, 4. I think I remembered you.
Oh, not 4, but look at these, 2 and 3.
Wait. Let me go back. Oh, 2 and 3.
So if I hit 45 first, then I go to math, left, and I hit 3. So 3 NCR 2, boom, 990. So cool. Calculators can do that math in their mental brains. I don't know what I was going to say there. All right, let's go ahead to example 3. Let's try doing it with just by hand. We'll use a calculator to check our work just like we'll do for the homework. So Giovanni's, they have 11 different pizza toppings. I don't actually know that. I just made that up. But let's pretend that they do. I don't know if they have anchovies, artichoke hearts, any of that stuff, but let's assume they have 11 of those different types of things, and you plan to choose 3 of those toppings. How many different types of pizzas can you make just by choosing 3 toppings? Tell me what to do. Let's say, Rochelle, you're going to do the formula. Daisy, you're going to do the logic.
Ah.
So, Rochelle, you're up first.
Okay.
Formula. First of all, combination or permutation?
Permutation.
Does order matter?
No, combination.
Combination. So is it N something something?
So it's NCR.
NCR, all right. And that's going to be equal to, plugging it into our formula, we know it's going to be what factorial, blah, blah, blah.
11 over
11 factorial, right?
factorial over 3 factorial times it by 8 factorial.
Yep. 11 minus, I was about to write 8. 11 minus 3 factorial is 8 factorial.
Which equals 11. On the top numerator, it'd be 11 times it by 10, times it by 9, times it by 8, times it by 7, on, all over. 3 times it by 2, times it by 1, parentheses, times it by 8, times it by 7. That's the denominator. And then cancel out 8 and 7, so it's 11 times 10 times 9 over 6.
Yep, and you can even simplify this even further if you want, because it is 11 times 10 times 9, all of that divided by 6. But you can also say, well, 2 and 10 cancel out to just 5. 3 and 9 cancel out to just 3, and it's really 11 times 5 times 3. Do you see how I did that, Daisy?
What?
So I'll go back up here. Right now we have this, which is correct.
Right.
But since everything is being multiplied, I can simplify these. How many times does 2 go into 10?
5.
So I simplify those. I cross this one out, it's gone. This one turns into a 5. What about the 3 and 9? Yeah, that turns into a 3. So it's really 3 times 5 times 11. 33 times, or it's actually, oh, we can use our 11 trick. We can do this all in our heads. Ready? What is 3 times 5? 15. What is 15 times 11? You know the times 11 trick now. So the answer is?
It's 165.
It is 165.
Oh my god, that is so cool.
We did that all in our heads. Boom. And then check it on your calculators. After we do the calculators, Daisy's going to show us the logical way of doing it.
I already got in the calculator.
Oh man, so quick. So we're going to do 11 choose 3, right? 11 math left 3, 11 choose 3, boom, 165, which is what we got. Nice. All right, so Daisy, tell us the logical way of doing it once you're done writing all that down. 3 boxes, because there are 3 toppings. Inside those 3 boxes,
Wait, I'm a little bit confused. Can we actually still use 5 and 3 in the logical way as well? Or should we just like...
yeah, you can use this because this part is what you're doing right now, and once we do that logical part, then this all flows from there as well.
Okay.
So you don't have to do that part again. Just do this part, setting it up without the formula.
Okay, so it would be 11, 10, I guess, or you could do 5 and 3.
Well, just
But
set
10
it.
and 9.
Yeah. For now, we'll simplify later.
Yeah, and then you divide all of that by 3
By 3.
factorial.
Why 3 factorial?
Because it's number of...
Yeah, number of boxes. Yep. And then you'll get the same thing, because this is the same thing as this. The 11 minus 3 factorial were the ones that canceled out that part, the 8 times 7 times 6, all that. And then 3 factorial will give you 3 times 2 times 1, which will simplify out with the 10 and the 9, just like we did up here. And that will also get you 165. That's equal to 165. Perfect. That is all I have for the notes. That's how to do combinations in a nutshell. We're eventually going to be doing a lot harder problems, so just be warned. I'm starting off nice and easy now, and we're going to get harder and harder, building off this base that you'll have perfect understanding of. Any questions before you write the summaries? All right, go ahead, write summaries, and the homework is going to be on Khan Academy.